name is Jacob Nan, and for this video, my team and I have designed a one rotor induction motor calculator in the Y configuration. The objective of this project was for us to make a three-phase one rotor induction motor in Y configuration calculator. We have to design a graphical user interface that is able to make that is able to take in all appropriate values for the terminal voltages, frequencies, number of poles, sleep, motor rating, equivalent circuit parameters, and as well as all the predefined losses. And it is able to calculate the following: IL, PSCL, PAG, PCON, torque induced, and torque load, and all the overall efficiency, machine efficiency, as well as NM. In this video, we will demonstrate the program using the example. Thank you.
Hi, my name is Ketan Lal. We have designed a one rotor induction motor calculator, and according to that design, the codes we have used is like basically simple, right? There were some edit fields used in order to for the data inputs and the data outputs. Firstly, we computed some of the formulas which were required for the requirements of the output values which were needed, and the codes as follows, whereby we have used also some of the switches in the input data section, which converts the values from the, for example, in kilowatts to watts, and from percentage to the value, or the value to the percentage, which simply needs to be converted during the process of calculation. And the overall formula which were used were under the calculate callback button, which enhanced during the process and used to calculate the output data value. Thank you.
My name is Vishal Kumar. So the graphical user interface was made by my team. It's a very simple and interactive interface which can be used by anyone. The interface splits into two parts, input and output part. And the input consists of a terminal voltage, the number of poles, the frequency, the slip, which can be given in percentage or value, and other equivalent circuit parameters, and as well as the predetermined losses. And also we have to click the calculator in order to find the output. So for the output, we know that it's a line current, and a stated copper loss power, an air gap power, and a power conversion power, and induced torque, and load torque, efficiency, and the speed.
Hello everyone, my name is Dimil Prasad, and I'll be showing up an example that we will use to cross-check our values with our GUI. So the example is that our terminal voltage is 208 volts with the 2-pole, frequency is 60 Hz while connected, and the rated power of the motor is 15 horsepower. Our rotor resistance R1 is 0.2 ohms. Stator resistance R2 is 0.12 ohms. The magnetizing reactance is 15 ohms with the stator and the rotor reactance is 0.41 ohms. Our mechanical power is 250 watts. Our stray losses are 0, and our core losses are 180 watts with a slip of 0.05. So we'll use this example to check our values in the GUI we designed to see if it gives the accurate values. Thank you.
Hello, my name is Ravi Shaksan, and I'm here to compare the simulated values with our theoretical values. As you can see, we have already entered our values from our example in our input data input place, and upon clicking the calculate button, we will get our results as follows. Now when comparing our calculated values with our theoretical values, we can see that our line current over here is 4.8, and our line current in our app is also 4.78, which is similar but not exact. Will be discussed in further slides. Now looking at our stator couple loads, we can see that our value is 1,205 watts, which is in our app we have 1,203 watts. And now looking at our air gap power, we can see it is 13.4 kilowatts. Within our app we get 1.269 to the power of 4, which is almost the same. And now looking at our power converted from electricity to mechanical, we get 12.73 kilowatts. In our results, we get 1.336 exponential to the power of to the power of 4. And now looking at our induced torque, we get 35.5 Newton meters, and in our F we also get 35.43 Newton meters. Now looking at our load torque, we get 34.3 Newton meters, and in our F we get 34.23. Now looking at our overall efficiency, we get 84.5%, and in our app we also come close to 84.2%. Now looking at our motor speed, we get 3,420 revs per minute, and which is in our app we also get 3,420 revs per minute. Thank you.
To conclude with, the graphical user interface was created using the Matlab software. To do a manual calculation, it gives off a rounded off value. The interface is user-friendly, whereby it was constructed to aid the non-users to understand and easily use it. Hence, the app enables us to gain a highly accurate and quickly solve problems relating to the wound rotor induction motor. Thank you.